Okay, good evening. Welcome to
Math task number 21.
That's task number 21. So you said you were having a hard time finding a good problem you liked out of your algebra book today, so I just picked one off of last year's AMC8, and this is a counting problem, I guess, not really an algebra problem. But that's okay. How many integers between 1,000 and 9,999 have 4 distinct digits? That's a very interesting question.
Well, think about it like all the choices you have for the digits.
Okay.
So for the first one you have 9 choices. 1 through 9.
Okay.
And then let's see. For the next one you also have 9 because you can also use 0, but you can't use the one you used before.
Ah, okay.
So we have 9, and then you can't use the one you used in either of these.
All right.
That would be 8, and then you can't use the one in either of those. So it would be 9 times 9 times 8 times 7.
Okay.
Well,
Actually, here, I'm going to tell you, since the AMC8 is a multiple choice, I'm going to tell you what the choices are. 3024, 4, 536, 5040, 6480, and 6561. Those are what the 5 choices were.
well, since there's only one odd number, this could kind of be a little easy. So you're multiplying an odd number times an odd number, which would be an even number. And then an odd number times an odd number will be an odd number. And
Okay.
then times an even number, it's even. And then times an odd number will be an even number. So that only eliminates the last one.
Okay, so 6561 is out. Can't be odd, because we've got an 8 in there.
Well, any of these not divisible by 3. Well, 3024, the digit sum to be 9, which it has to be divisible by 9.
Okay.
So the digit sum to be 9, and so that one will work as a choice. And then 4536 will turn into 18, which is also a multiple of 9. And then 5040 is also 9. And then 6480 is also a multiple. It's also 18.
Okay.
But we can eliminate both of these actually.
Why?
Because we don't have a 5 in here,
Ah.
so you can't get a 0.
Ah, you can't get a 0, so those are out. So just by doing a little bit of thinking, we avoid some probably complicated multiplication.
Yep.
And now the question is, which one is it, 3024 or 4536?
Well, let's see. Could divide each. They only divisible by 8. We could divide each of them by 8 and see if we get an integer. That would kind of divide them out.
Yeah, there's an easier thing to look at though.
Well, divisibility by 7.
Well, we don't know the divisibility by 7 rule. What's different about 3024 and 4536?
Well, 3024. Okay, yeah. 3024. 34, 456 is larger.
Yeah, it is larger. Yeah.
differences.
Well, look at the last digits. 4 and 6.
4 and 6.
Okay, so how can the last digits help us?
Well, the last digit, well, if you multiply these last digits together and you check the last digit should be the same.
Okay, so what's the last digit of 9 times 9 times 8 times 7?
Well, 1 times 9 is 81, so that'll leave 1 times 8 goes to 8, and then it goes to 6, so 4, 5, 3, 6.
Yeah, see, the last digit's a super snap.
I guess we could have used that from the start.
Yeah. But you can also do some estimating too. I mean, 9 times 9 is 81, which is about 80, right?
Yeah.
And 8 times 7 is?
56.
So what's that about?
80 times 56.
So 80 times 56, what could we estimate 56 is very close to?
50 or 660.
Okay, so this is close to 80 times 60.
Which is 4,800.
Yeah, that'd be another way we could look at it. Anyway, that's a nice job. You got 9987 really, really, really well. That was a good job. You're welcome.